recruiting and search firm that focuses on data analytics and helps companies find talent in the AI, machine learning, and advanced data space. Work with customers in Georgia as well as across the U.S. We have a real exciting program for you this afternoon to kind of kick off our society's series for the year. Our very own board member, Dr. Chaz Level, will be moderating a panel of experts that are going to be discussing explainable AI. It's an interesting topic, which is getting, depending on your level of experience in the space, it is or maybe isn't getting in a focus or getting focused. So we're going to talk about what it is. We're going to talk about what it means and how it could be implemented into your workflows. So we're excited about that. Before we get started, I just want to go ahead and talk a little bit about our society. And by the way, Dr. Lever with Chaz will be introducing our panelists. You'll get to know them a little bit later on in the program, and a little bit more about their backgrounds and why they're so cool and why we want to hear from them on this topic. First of all, I want to thank our 2021 society sponsors. TAG as a whole in our society does not exist without the support of our sponsors. For 2021, they're Integra Connect and Emory University. Emory University is also a sponsor for our TAG Data Talk monthly podcast, which is available to anyone on our landing page. If you go to tagonline.org and you go to the Data Science and Analytics Society page, you'll see a link to all of our podcasts. And this is something that we offer as a service to the community and to the ecosystem. It's facilitated and narrated by our own board member, Dr. Beverly Wright. She does a great job. If you have Alexa or if you have any other service that leverages, my Alexa just went off, that leverages a podcast service. If you ask Alexa to play Tag Data Talk, you'll probably hear it in the background here. She'll probably go and find it and serve it up for you. So remember that we do have that Tag Data Talk available, and it's available through any of your podcast services. Also want to, before I make this intro, really want to thank our event sponsor. These events are individually sponsors, and we're lucky to have Blair Newman, who's the CTO of Newton.ai, a great service. And so what I wanted to do before we turned it over to Chaz in the program, I wanted to go ahead and introduce Blair and give him the floor for a few minutes to talk a little bit about Newton and the types of problems, the challenges that they're solving for customers. So Blair, without further ado, I'll turn it over to you.
All right, thank you, Tony. And if you don't mind, maybe if you can give me an opportunity so I can share a few slides with everyone, I would appreciate that. And again, just I want to take a moment to kind of extend my thanks to TAG as well as yourself, Tony, for giving me the opportunity to not only be a part of this program, but also have an opportunity to kind of share some of the things that we're doing today. And probably for most people, you may be a little unfamiliar with our organization, Newton. Newton, as a company, we've been around for a little over 17 years. And over the last, I would say 7 to 8 years, we've been fairly evolved and fairly active, I would say, in the ML space, more recently in the auto ML space. So just to kind of give you a brief overview, kind of what really excited me to be a part of this program, our solution is really, Newton is really designed to kind of really target a number of different demographics, but primarily we're looking to focus on bringing machine learning really to everyone. So since we are an auto ML solution, one of the things that we've done is we've really focused on reducing our pipelines to 3 very simple steps. So whereas whether you are a data scientist or whether you're new to machine learning, you have an opportunity to take advantage of our platform and oftentimes be able to produce predictive models within a couple of hours. With that said, today's topic is around explainability. Now, explainability is an area where we've really taken a number of significant steps as it relates to machine learning. So some of you guys may know, or you may just be getting introduced to, that specifically around machine learning or neural networks, being able to understand what is specifically driving an individual prediction is extremely important. One of the areas that we've been focused on is in the financial services industry, and whether they're looking to understand if someone will default on a loan, if whether or not they will even approve a loan, being able to have insights as to what is driving those individual predictions or recommendations is extremely essential. So we've really taken a dual approach around explainability. Number one is understanding the quality around your models, and number two is understanding, let's say, interpretation. What is actually driving and causing a certain prediction? And that's what I'll just like to share with you guys briefly today, if you don't mind, just our approach to it. And when we take a look at it, we take a look at it in really kind of three very distinctive steps: how we're analyzing the data prior to training or creating a model. What is the actual model quality? Because of course, accuracy is extremely important. Then once you've actually created a model, what is actually driving those individual predictions along the way? And then lastly, once you have a model, what is the quality of that model over time? When should you maybe actually begin to consider retraining those models? And I'm gonna just take very briefly a couple of minutes to kind of share with you guys what's our approach to explainability. So hopefully you guys are able to see my screen where I just gave that overview, and hopefully my next screen will come up. Here we go. So we start off first what we call our EDA. Our EDA, our exploratory data analysis tool, it gives you an overview as to what your data looks like before you actually create the model. One of the things that we do is we highlight the 20 most important features as it relates to your data before we even begin creating the model. So you have some insights as to if there are any outliers in your data, if there's any bias in your data. We give you that insight up front. And keep in mind, one of the things that I'm discussing is I'm discussing a fully automated machine learning tool that at no point does it require any coding along the way. This is something that we automate 100% completely. Next, one of the things that we do as we begin to train and create your model, we provide you what we call a feature importance matrix. We provide you the top 10 features of your data that are influencing your predictions, and also, which can be more importantly, to understand what are the bottom 10 features that are actually not influencing your data. Because a lot of times we work with customers where they think there are some features that are influencing your data, but in reality, it's not. Now you get to the point where you actually have a model. One of the things that we provide visually, as well as from a metric perspective, is how your model is performing overall from a quality perspective. And we provide a variety of different metrics so that you can understand how it performs under any given circumstance. So visually, we provide you this as well. Now, this by far is our most popular tool. It is a leading edge tool. It's what we call our model interpreter. Now, our model interpreter allows for you to dynamically change the value of any feature in your data set, and you can see visually how it may influence your prediction. So if you're working with a classification problem where it's either yes or no, you can change the value of each feature to see if whether or not it may change a given decision. This could be important if you're looking to identify customers that are at risk. This could be important if you're looking to identify your ideal customer profile and you want to create that ideal customer profile. You can use this tool to dynamically change your features and see how it actually influences your prediction, which is essential, at least for us, when we're working with a number of different financial institutions, as well as some other sectors along the way. But this is by far one of our most popular tools that we have. And then lastly, it's a very extremely long name. It's called the Model to Data Relevance Indicator. But what this dashboard does is it begins to let you know if your model is beginning to decay, if whether or not you need to retrain your model, if whether or not your model is now seeing data that initially you didn't expect to see along the way. And then lastly, as I begin to wrap up, I just want again, not only extend my thanks to TAC, but also extend my thanks to all of you guys for giving me a few minutes to give you a brief overview of our AutoML platform, Newton, which we believe goes a significant way, not only as it relates to helping individuals, deliver models, implement models, but also understand what's driving the decisions behind those models. So with that said, again, I extend my sincere thanks for you guys giving me the time. And I think I'll have it over to Chaz and we can all now enjoy the panel discussion.
Sounds great. Thanks. By the way, real quick, Chaz, Blair, your contact info, I've included it in the chat, your LinkedIn profile. So if anybody wants to connect with you offline, I've included his LinkedIn profile. You can connect with him that way, if that's okay.
All right. Thank you, Tony.
Awesome. Well, super excited about the panel that we have today. And, I know Tony flashed up a slide earlier with the panelists, but just kind of want to give you a little bit more background on each of our panelists before we get into the discussion. One of the things I'm super excited about with this panel is that we were able to bring together panelists from a variety of different backgrounds, from academic space to government, from NIST, and as well as the industry. So we have a variety of different backgrounds and from different kind of spaces that we're actually going to be pulling expertise from. So I think that should lead to a really interesting panel. So just to start the introduction, we have Dr. Polo Chow. Polo is an associate professor of computing at Georgia Tech. He also co-directs the Georgia Tech's Masters in Analytics program there. He's also the director of industry relations of the Institute for Data Engineering and Science. And he serves as the associate director of corporate relations for the Center for Machine Learning at Georgia Tech. And his research group there bridges machine learning and visualization to synthesize scalable interactive tools to make sense of massive data sets, interpret complex AI models, solve real-world problems in cybersecurity, work with human-centered AI, graph visualization and mining, as well as leveraging these for social good. He received his PhD in machine learning from Carnegie Mellon, where he won CMU's Computer Science Dissertation Award honorable mention. And in addition to all of these accomplishments, he's received numerous awards and grants from a number of industry and government agencies, including NSF, NIH, NASA, DARPA, Intel, Symantec, Google, NVIDIA, just to name a few. And beyond that, his research group has published at a number of the top academic conferences where they've received, runner-ups for honorable mentions or best paper awards at a number of the major academic security conferences. Next we have Karina Han. And Karina is a social scientist at the National Institute of Standards and Technology. She received her PhD in cognition and neuroscience from the University of Texas at Dallas. And her research primarily focuses on evaluating face recognition accuracy in humans and automating face recognition technology. And so this work that she's done was recognized with a gold medal from the US Department of Commerce, which is the highest honor granted by the secretary. And as part of NIST Explainable AI team, she's contributed to characterizing the properties of explainable artificial intelligence with a focus on considering the human aspects of human-machine collaboration, which brings a kind of unique perspective to this panel from this kind of human-centered aspect. And lastly, she has her research, multiple disciplinary research can be found published in numerous high-impact peer-reviewed journals, including the proceedings of the National Academy of Sciences, as well as the proceedings of the Royal Society and also ACM SIGGRAPH. And our last panelist, Rajiv Kaushik. And Rajiv is a data science product manager at FIS Global. FIS Global is a Fortune 500 company that's included in the S&P 500, and it's one of the largest financial technology firms in the world. And globally, they move around $9 trillion annually. So huge scale. And obviously, this is one of the reasons why kind of data analysis is very important for them. And Rajiv has worked across a number of different industries and open source foundations, leading ideation, design, and development of data-driven products. And these products leverage value derived from the underlying systems they're built on top of. He's also an expert on APIs as products and speaks regularly at industry conferences like Product World. And we're really fortunate to have Rajiv on this panel. He champions design thinking for new and innovative use cases, leveraging machine learning. And one of the great things is in his work, he believes that explainability starts at the very beginning of the product lifecycle rather than viewing as an afterthought. And so he provides a great level of insight here on why explainability matters. And as a data science product manager, he ensures that the products that he's building serve commercial needs, as well as keeping privacy, safety, and security of customers top of mind. So very excited to have all these different panelists and kind of have their views to kind of talk about this topic today. So before we get too far, obviously we're going to be talking about explainable AI. And so I think this is a great time to actually, start asking our panel, what actually does explainable AI even mean? So, some of you may not be familiar with the topic, or you may not be familiar with why we even need this. So, one of the questions that I think is interesting to start with is, what is explainable AI, and why isn't looking at the output of a model enough? And what kind of value does it provide? And so, maybe, Polo, if you want to start us off and maybe provide kind of what this kind of topic is.
Sure. Yeah. So I opened by saying explainable AI is a buzzword. So to different people, they mean different things. And that's actually a debate in academia. What does explainability mean? Some people say, oh, it's the same thing as interpretable. Sometimes they say it's not. And then even for explainability, interpretability, they say, well, what are some aspect of it? Also, there's a whole paper you can read about it. Many papers actually read about it. So to me, I think a more practical approach is I want to look at the problem that people want to solve, and who are the users, who are the people that we're developing these AI technologies for, and really start from there. So I'm a huge proponent of another buzzword, human-centered AI. But again, that really is really talking about how are you helping people to solve that problem. I don't care about really your approach. I don't care about what you're using in it, but I just want people to know what they are getting. So that's really means it's getting at when you have a result, why do you arrive at the result? Right? So as in, are you using some part of the data? Which part of it? Are you using some techniques? What are the techniques that are doing? So can you help people understand those approaches and data? Not really showing all the details, because people get overwhelmed. So that's where a lot of the research is going in, is to look at how to appropriately show sufficient and succinct amount of information, so to help people make decisions. So that's our general view on it. So yeah. Oh, I think you're muted.
I think a kind of a natural follow on to that is, so Rajiv, coming from a product management perspective, managing a data science team, how do you kind of go about when you're building models and things like that you have, team members building this and you have customers using it? How do you go about kind of building this explainability in this or interpretability piece, or just helping humans understand what's going on?
Yeah, the first thing I'm going to say is that for me, for my team, client experience CX, customer experience CX comes first. So we always put ourselves in the shoes of the client, of the customer, and really put ourselves in their shoes, in their body, in their brains, and say, if you cannot explain it simply, you just don't understand it well enough, right? That's what Albert Einstein said. So I'm going to quote that. As a customer, I need to be able to understand why a decision was made. I understand why not. I know when to trust you, and I know why you made an error, why you erred. Right? So at the end of the day, explainable AI essentially helps us trust the algorithm at the end of the day. And in the industries, helps the regulators understand what you're doing, that it's well documented in the system, so no one can say, I don't know what happened. You have to be able to explain why it happened, what were the drivers, and who's accountable for what's happening under the covers. So that's my first perspective as a product manager coming in from a client perspective. So anything that we do in the product lifecycle, whether it's early on in the design thinking phase where we're ideating a product, when we're experimenting, when we're prototyping, we always apply that philosophy to say, what will a client or a customer say? What will they want? What are the risks? How can we mitigate the risks? What are the trade-offs between transparency and accountability? Thank you.
Awesome. That's great. Yeah. So, I mean, really kind of what I'm, there's kind of a theme that's kind of building here, and which I think is going to continue throughout, which is really, this is, breaking past the kind of the buzzwords of explainable AI and stuff like that. We're really talking about helping humans understand and interpret these models and kind of make sense of what's actually coming out of this. And so there's a very important kind of human component here. And so, Karina, coming from like your background, which is more focused on the human side of things, what are like the challenges to actually providing this level of understanding to humans?
Yeah, it's a great question. And I think Rajiv, in his explanation, really highlighted the difficulties in this. So you want to tailor this explanation to this human that will be consuming the explanation, and different people might expect very different things from an explanation. So for instance, if I'm a person applying for a loan and I get some sort of decision from my application. So for instance, I'm rejected for a loan, I might want to know why, and I might want to have explanations like, finding out like, was it my income that was too low? Is it that I have, charge-offs in my credit report? Things like that. Now, that might be what the stakeholder wants. Now, the actual, institution might want something different. So they might want, more, if I'm the developer of this system, I want information, for instance, to help me debug it. How can I make my model more accurate? How can I, tailor things to have better predictions, et cetera. So those explanations for that user and for that developer are going to look very different. So, there's really no like one size fits all explanation, even for one system. So yeah, it's a real challenge, but those are the sort of contextual contents that, can really be considered when producing explanations. You're muted, Chaz.
I'm very mad at unmuting myself. I'm
Okay.
sorry. That will probably be a consistent theme. I just want to talk. So I mean, yeah. So that like, I think that's those are some great points and things that we've again, going down that route of kind of the human component being very important, and it's different to different folks. So what are, if dealing with this kind of idea of and making it easier for humans to understand things, are there any like kind of key principles when we're going about trying to make our models and make these things more understandable to humans? Are there any key principles that stand out that are important in this space? Maybe Polo, do you have any thoughts on that?
I'm sorry, could you repeat the last part? I think
Yeah. So are there, when we're trying to go about building models and other things that are more understandable to humans, are there any kind of key principles that we should kind of adhere to?
Yes. Yeah. So there are some guiding principles, and first is that knowing the limit of human beings. So one principle we use a lot is how to not overwhelm people. So there's a famous study that look at how many things that people can really hold in their head at a time. It turned out to be surprisingly small. We have a really great long-term memory, but short-term memory, or what we can hold, is like that usually says 7 ± 2, but that's like many years ago. So now it's more like 5 ± 2 as we use more mobile phones and everything. So what that really means is that showing everything on the screen or visualizing everything on the screen does not mean that people can really understand that. So we are guilty too. Like, we're working on visualization. Often we just say, hey, as you can see on the screen, and I just here's the screen, and that's not very effective. So more helpful, and that's also our guiding principle, was to determine what is it that is relevant or helpful to people at the time they're doing the analysis. And that is something that can change, which also means that often static things, just showing a result and just like one version of a result and hoping that that will help with their task, usually that doesn't work. So things need to be more interactive, as in you base on the interaction, the system interaction with the user, the people, and then learn about what they're interested in, and then kind of improve the explanation and inference. And this is actually something we do see a lot in a lot of products, right? So for example, the tech company, they're pretty good at it. So recommendation, you can draw in techniques from recommendation, trying to inference. So same idea there. So actually search engines, you can, for a long time, you search something in the web, like Google something, for example, they only give you like top 10, top 20, and so on. The reason that they can do that is based on relevance. But now you can apply the same principle technique now to explanation, and not just really showing every single detail of what you're trying to show, but determine what is most relevant and then prioritize those. Yeah.
Again.
Oh,
there we go.
Yes.
I'll get it. I'll get it eventually. So we actually had a question pop up from the audience that we might field now, I guess, which is, kind of based on these things, where we're kind of generating things that are interpretable by humans or understood by humans, or kind of building on this kind of human understanding piece. Do you think it's likely that we'll ever see these kind of methods lead to something that is produced in kind of media and journalism? So like that will lead to more kind of, rather than, humans are inherently biased, in our views. That's something that, any sort of impartiality we try to have, we probably have some biases to stand there. Do you think there's something in kind of this building these models where we can build models that are less biased than humans, that maybe generate output that would be more logical truth and not as biased?
Well, I think that touches on a really important thing to remember, and that these elements that build trust don't live in isolation. So explainability lives among other, principles related to trust, or that we think foster trust. And one of those can be bias. So if a system is biased and it's known to be biased, that breaks trust. And the way those two can intersect is potentially the explanation could possibly expose a reason for bias. And that then can help, tailor the training, tailor the model, et cetera. So in terms of like deployment, that can look very different, but that intersection, I think that question really, really highlights the fact that, yeah, these are all intersected principles that can all, help each other.
I'll throw in my 2 cents. I think we're a long ways away from being able to flag and shut down fake news. I think we've started to make some advancements, especially in the last couple of years, led by some of the big names like Google, the Big Five, and others. But I think we're still a long ways away. There's quite a bit of research that's being done, and I'm sure, Polo, you are plugged into some of those. But this is one of the hardest problems as it impacts our daily life.
Yeah, and certainly I think kind of going back on algorithms and generating things that look like they're human generated, and kind of having that. I think one of the things that was very popular recently was I think OpenAI had like GPT-3 that came out in terms of taking large bodies of text and generating stuff that seemed like it was reasonably generated. But I think one of the challenges there, and Paula, maybe you can comment on this, is understanding how it got to those what it actually generated. I mean, it generates things that seem kind of human sometimes, but like it doesn't seem to actually have understanding. So how do you make sense of how it even got to the thing that it wrote?
Oh yeah, sure. A lot of it is really machine learning doing a lot in the imitation. So often when people say, "Oh wow, that is such a intelligent AI machine," it's a lot of time it's imitation. And then the imitation is like pulling a bit from here, from there, and a lot of it from data. And also a lot of these methods are what we call probabilistic. So they're not very deterministic. You could, for some methods, you can ask them the same question depending on the time of the day. They call it initialization. And yeah, you can get different results. So in some sense, it's where a lot of these issues like trustworthiness, bias, and things, issues like that come from. Is not very deterministic. And in some sense, you can say like human beings are not very deterministic too. But a challenge for the these AI method is you just don't know unless you really look. And even if you want to look, it's not easy to look. So like for these methods like GPT-3, they're so complex now. I mean, even for state-of-the-art techniques and research on explainability is not even getting there yet, because just knowing how to, we call open a black hole, so how do you open a black hole, and how do you like look at like where to poke, that require a lot of effort. Yeah.
Yeah, absolutely. I think that kind of pokes at the challenge is that as the models become more complex and things are getting harder, the explainability is very important, but it becomes harder as well. Especially more poking at things like the black box models, which have become very popular because they've shown promise in some things that we've had, I guess, difficulty before. But this kind of leads to another question, which is, we are talking about kind of making methods more interpretable, making methods more explainable, but how do we even go about evaluating what more interpretable or more explainable even is? Karina, do you have any insights on that from like the human perspective there?
So it's a great question. And there is the most research I've seen on this typically is done in the form of presenting explanations and then getting a judgment from humans of whether that explanation increased their trust in the system, helped them understand, et cetera. So there is work on this in terms of getting human judgments of explanations. That's potentially a path forward to help make explanations that are meaningful to humans. But it's really hard because, as Paula pointed out, even one human isn't necessarily static over time. So for instance, an explanation that is, maybe confusing or meaningless to me at some sort of point in time, as I gain knowledge, as I gain context, et cetera, I might want more information, different information. That information that I saw initially might not be sufficient for me anymore. So there's not really like a perfect answer, but we can consider those sort of aspects as we try to make the best system, or at least make a system that's interpretable.
And Chaz, I would like to extend that and maybe come from a different angle to say, when we evaluate these approaches, I think there are 5 key aspects or components to consider. The first is drivers of the decision, being able to measure that. Second is responsibility. Where does the responsibility lie and who can be contacted for further info, right? What's the data being used? How fair is it, and what's the explanation of fairness? What steps were taken to unbias the model? Explaining the performance, the accuracy, and the reliability of the model, which is where we tend to spend a lot of our time. But I think these other 4 are also very important. And then last but not the least, evaluating the approach also needs to involve explaining the impact. If we screw up, what's the impact on individuals, businesses, government, society, and the environment, right? So all of those facets must be considered in any sort of an evaluation model.
Yeah, and I'd like to add to that as well, to consider that in terms of explanations, as you just mentioned, Rajiv, a lot of work has gone into like evaluating the accuracy of the model. Relative to how much work has gone into determining the accuracy of a model, the work towards determining the accuracy of an explanation, this work is really not existing to the same degree as measuring those decision accuracies. So when I get an explanation right now, how I can have some sort of metric to determine how faithful is that explanation to what the system actually did, metrics to evaluate that are, to my knowledge, almost, really non-existent, although I know that this is, work that is being developed, but maybe others on the panel could speak to current metrics for that. But yeah, as far as I know, that's really not been done. So that's a challenge too, as we consider like, well, what's the best explanation for a person? One of the key things is, well, the explanation should be accurate to some degree. And so at NIST, we wrote a 4 principles of explainable artificial intelligence draft that went out for public comment. It's being reviewed right now, but we pointed out sort of 4 key things in a system are: one, that an explainable system produces an explanation. It's not an explainable system if it doesn't. That it be meaningful to the person, that the explanation is accurate, and that the system has some sort of ability to express its knowledge limits. So for instance, if it's a bird classifier and you input an image of an apple, ideally the system would say, I don't handle that type of data. So those are the kind of key principles that we've pinpointed. But yeah, in terms of measuring these things, yeah, that's another step forward in terms of the research.
And the cost of not getting it right or close to right can be huge, right? False positives in my industry have cost the banking industry and then also the retail industries billions of dollars in lost business as well as reputation. Some of us may remember, was it last year or a year before, when Apple came out with their first credit card, their tie-up with Goldman Sachs. They were actually challenged on how they were decisioning who to give credit to and how much credit to allocate. Right? It was a very famous study. I think there's also a case study we should be able to find online. I also go back to the crash, crash of 2008 in the financial markets. What was labeled as toxic CDOs and loan obligations, while that didn't involve AI, they lacked an audit trail, the likes of which an explainable AI system really tries to create. So at that time, the market was largely unregulated, and the origins of those trades couldn't be traced back because of the nature of software. We're still trying to understand to a great depth a lot of what happened as the dominoes fell.
Yeah, it's funny. So mentioning the kind of the real world impacts of things actually kind of touches on another interesting aspect of kind of this line of kind of work and this line of study and kind of why it's important. And I think this is, we have machine learning being incorporated in more and more aspects of our lives. And so we're seeing, it show up in things like cars. We're seeing it show up in, in places where like the real world repercussions, might not just be financial impact, but maybe, there's human life is something that's at stake there. Certainly if we're, applying these things in healthcare or other places. So are there ways that like we can actually use this kind of explainability or start to build this into models or understanding the data better that can allow us to maybe have more trust in some of these systems, or to understand when we shouldn't trust the system, to understand when it is not making, models, or not making predictions based on anything that seems reasonable or that we believe should be something we would put our faith in that?
Yeah, I can say a little about it. So short answer is yes, it's possible to incorporate explanation directly into the method, but it's not necessarily easy. Some classical method, for example, like decision tree based or some regression based. So those are easier as in the method, and also some GAM generalized regression, basically. So those by design of their algorithms are easier to do. So you could already do it today. Some of the more recent models, particularly these deep learning models, much harder. Because again, that people don't even know necessarily like what part of the model to show or to explain, and also like how the different parts are connected. Is active research area, and also including my group too. Is we really want to try to tease out like what is the important thing from the model and how does that contribute to the explanation. Not easy, and currently a lot of work and research is based on what we call a post hoc explanation. So as in you already have the model developed, trained, making decisions already, and then now you're going to want to use the explanation or visualization interfaces to really understand, kind of in hindsight, in some sense, like what is it that the models is using to help with that. There's a gap, as you pointed out, that wouldn't it be good if we were making the decision already or during a training time, even before the model is built, or during it when it's built? Can we help with explanation? There is, we still need a lot more work there. So we, a big gap in that space. Yeah.
So based on that, kind of we have some models which I guess lend themselves more naturally to kind of being understandable, at least by humans, and then we have some things that are more like kind of black boxes that we don't really fully understand how they arrive at their explanation. We put stuff in and we get an output out. Given some of the places that machine learning is being used, does it make sense to limit the type of models we're using to solve certain problems to things that we can more reasonably reason about?
So I'm not sure I'm going to answer your question exactly the way you asked, but I'm going to state an approach which tries to. Okay. If I was a business owner, business leader, and I was starting off, I would start with the assumption of full transparency. Okay. Then, as the information is limited, I should be ready to explain why a certain piece was limited. And there's two kinds of transparency: explaining the features which drive the model outcome. Why did I decide to downgrade certain features? Why were they in my bottom 5 or 10? I think Blair was referring to this earlier, and I really like that sort of approach. And I also need to be transparent about the process of how the model was developed, where the data was sourced from, how it was balanced, so on and so forth. Have to be very transparent about the process and the people involved and where the accountability lies.
Yeah, I think that's kind of important. That's certainly a very important thing to kind of keep in mind. And I'm kind of like thinking about, in some cases we're making decisions about things based on the outputs of models that, maybe in the past might have been humans analyzing data, but now we're relying on the outputs of models. And I think, kind of looking at like an example that illustrates why this is maybe why that illustrates some of the challenges here is, I remember it was a number of years back when Google did like their famous flu study, where like they analyzed the results of traffic trends for Google, and they estimated it was going to be like an unusually high flu season or something like that, or they misestimated something based on those trends. Is this one of those things where, for certain aspects of our life, we shouldn't probably trust just the model without being able to explain why the model got to a result? So kind of going back to that same theme of are there certain areas where it's acceptable not to be able to understand the model because the results are not okay, and in other places, you know, we probably need to be more cognizant of the models that we're using, and maybe given where the state of the art is today, should we limit the types of models we use to kind of we use in certain areas?
I can probably start to say a few things. And generally, I think we call high stake, higher risk, the more explanation, or at least the more desire to explain, I think. So that could mean, yeah, self-driving car, for example. Personally, I think it's very important to know. And also health and healthcare, I think, and also I think in the security related applications too. I think those are important. And also now these days, also like criminal justice and those, I think we are getting at that too. Is kind of surprise that a lot of people don't really think about it. That, oh wait, what, you have been using system to help determine like the length of term for like a decision. So yeah, people don't know that actually. But I think generally, the more high risk or high stake, then the more desire that we should have. And I think generally, again, when we're getting into overarching that desire is really, if something is really probabilistic, as in you, depending on what our human beings would consider as pretty much the same situation, but then somehow the machine would give different answers, then I think we should question it. So everyday example, like self-driving cars now, all the height, I mean, actually the height is a little bit lower now, but it would make mistakes. It would like make these mistakes that you say, what is happening? Why would a car ram into a stationary fire truck? It doesn't make sense, right? So I think that is where we really want to question it, and don't buy so much into the hype and just say, hey, just trust us, we have this technology there. Yeah, I think that's an everyday example. So anything that times it doesn't make sense and yeah, give you different answers, but seemingly the input is the same, I think we should question it. At least that's my academic, yes.
Yeah, I think that seems totally reasonable as well. And you know, kind of just like building off of that, like we've seen, you know, our society's put on some events talking about the topic, but we've seen like ethics kind of an AI become something that's become a bigger topic of discussion these days. And a lot of that, you know, kind of deals with things like bias and using machine learning in places where we might not fully understand things. So, you know, it seems like there are applications here for like, you know, addressing things like fairness and maybe privacy and other things by having more explainable models. And maybe Karina, do you have like any thoughts on like how, you know, some of the explainability can like lend itself to, you know, maybe lending more fairness or privacy or things like that you know we care about as humans into these decision-making processes?
Yeah, absolutely. So it's something that at NIST we've been thinking about a lot. Sort of this core building blocks of trustworthiness, explainability being one of them, and as you pointed out, privacy, bias, robustness being other really important elements towards fostering trust. And again, these sort of building blocks don't always live in isolation. And here the idea with explainability is that, hey, maybe explainability can help shed some light onto those other important elements. So as I mentioned earlier, an explanation may reveal why some sort of decision is biased. An explanation may help a user understand the robustness of whatever they're using, whether they should use it in context A or context B. So like, yeah, these really live together. And we actually, we held a workshop at NIST focusing solely on, or one of the panels was focusing solely on this topic. It is such a big topic. This panel was, like an hour something long, and there's so much more ground to cover. But right now, sort of what we're hearing and what we're sort of noticing is, those intersections seem key, and that considering those intersections can perhaps, make a more overall trustworthy system.
Yeah, that's awesome. It's interesting because coming from like a security background where it's an intersection of machine learning and or data science and kind of security, one of the things that I've seen is machine learning and security has been a big buzzword for a long time, where it's like, let's automate more things with machine learning, but we send things to a SOC or an analyst or something like that, and like they get alerts that are based off of these models, and those models might get an alert that is wrong, but they have no context about why it's wrong. Or they're dealing in an adversarial setting. So like you mentioned, robustness and reliability. So we actually as a society put on an event last year on kind of adversarial machine learning. And so it's kind of interesting seeing an intersection here with the explainable AI and potentially with like this kind of idea of adversarial machine learning and how there might be an interplay there. I don't know, Polo, given your background in security and machine learning, how do you feel that explainable AI could it help kind of building more robust models, as well as kind of dealing with this adversarial type of attack?
Oh, definitely. Actually, we are currently working on a DARPA project called GUARD. We're one of the performers. So it's a 4-year project, 4-year program. GUARD stands for Guaranteeing AI Robustness Against Deception. So the whole DARPA program is about coming up with defenses for AI models. So if you want to do, let's say, self-driving car, and sometimes the adversary is actually nature. Maybe not surprisingly, is nature. So you shine a bright light on a very sunny day, you get reflection, things you just don't see it. So what that could mean is if you rely only on camera systems as the main input, you are blind. Like your camera doesn't see. So that is the kind of natural adversary. But you can also imagine there may be people who will be have a more determined to really crash the car, right? Or then those are kind of another adversary. And we know now from research that you can really crack the AI model. It's actually not that hard. If you really want to do it, you can do it now. You can fool a image classifier. You can even fool object detectors, which for a long time is believed to be very robust. The object detector that's used in driving car, for example, that given a video, right? So you can know where the people, where the trees, those are actually pretty fragile also. So definitely, so my view, my biased view, it's very important to understand what these techniques like object detectors, classifier are really doing. And if you talk to any researcher we're actively working on adversarial machine learning, working on computer vision, if you ask them, hey, how does your method work? And usually they say, oh no, just believe us, it's working well. And to me, again, I think it's because of the high stake nature of it. It's very, very important to know. And if you have a techniques that are really working well, why is it? And also and particularly for cases when it does not work well, it could be either under attack by someone intentionally doing it or just by nature. So again, going back to the example, why would the car run into a fire truck? Yeah, why would accelerate even going to it? I think we really need to know. And not just say, oh, that's isolated incident. No, not really isolated. It's something in the model that's making it happen.
Yeah, that's fantastic. So I mean, it's interesting. There are a lot of intersections with kind of being able to understand these models and effects on policy, effects on kind of building models that we trust and provide more fairness or have less bias. There are a lot of implications for why this kind of field is very important. And so at this point, I imagine there are a lot of people that are kind of well, yeah, this matters. It seems important. How do I even get started with incorporating more of these kind of the techniques and frameworks and things that will help me understand the models and things that I'm using better. So Rajiv, are there any, for your team, are there any kind of tools or techniques or things that you guys use to kind of help, build some of this interpretability into the things that you're generating for customers as well as that you're consuming yourself?
Yeah, that's a really good question. It's a constantly evolving set of practices, I would say, more than tools, more than the standard tools that are available inside of AI. We sincerely believe in design thinking. So what we do is from the get-go, from the ideation step up front in the product lifecycle, we constantly ask the question, is this explainable? can this be explained? If we explain it, is it going to cause any sort of downstream impacts to our business, to our intellectual property? Is this going to have an impact on customers? What kind of lawsuits can we get to? So at every step of the way in our product lifecycle, especially upfront when we're ideating and doing the design, we factor in explainability as a key objective. So when I, as a product manager, hand off a set of requirements to my data scientists to go develop, tweak, tune, and evolve a model, a lot of those requirements are surfaced in my specification to them. And it's not just a one and done, hand it off, and we're done. It's always a continuing discussion. One thing I would say is that, and I'm going to go on a slight tangent and put in a plug for Gartner. Some time back, we actually really, based on Gartner's recommendation, said while we're preparing for AI, while we're doing our homework, data engineering is the most important aspect for us to prepare for AI, for us to be able to get better, more accurate models that we can explain easier. So focusing on data engineering has been another practice that we do, not just from a technical perspective, but also from the business and the product perspective. And there are various things we can do from a product and a business perspective to look at the life cycle of data, to analyze the data as to how data can be transformed, cleaned, quality improved. So downstream, when we're actually doing the modeling, we'll have a less difficult time explaining what's going on or what the outcomes of the decisions are.
Yeah, that's awesome. And I think I'm sure people would be interesting. So Polo, your team has been developing frameworks and things to kind of help with this. Like, what types of things are you guys developing that could be applicable to people that are putting models and stuff into practice today?
That's a good question. Yeah, there are, I think, for the explanation libraries, that's a good question. I don't know where there are explanation libraries. There are some tools I know that you can do kind of post hoc analysis. For example, like from Google, there's a what if tool, and you can use it to really, pick out, okay, so what are given a data point, you can ask questions like, oh, what are the another very similar data point similar to what you're looking at, but then the result will be flipped. So that could help you get a little bit at what are some features that the model could be using, so you can do some inference there. But I think if you're looking about very kind of holistic general toolkit, I don't think there is, as far as I know, not really yet. A lot of the system currently is really built around particular technique or class of techniques. So I think there's a gap there, but also at the same time, not very surprising because it's still relatively a new space, and it's natural to start thinking about, based on what people already have, how does that explanation help them for the particular case. So so that, I think that would be an answer for now. I think there's some tools that are starting to emerge, but like a very general framework, not there yet. And also, actually, I'm not sure it's necessary. That might be the way to go, because a lot of, I would say, all explanation often is really application specific. And once you get to applications, then that means you may need a lot of features that are unique to the application that may not just generalize.
I think that's
I should mention, as a product manager, sorry, I should have mentioned, because I think this is a very important tidbit. As a product manager, I always put myself in the shoes of the customer and say, if I was declined credit and one of those features or drivers was changed, would the decision be any different? I think this goes to some of the models, especially Lime, that leverage that sort of an approach. And we always try and do that to say, what would change the decision? What would take it over the threshold or pull it back, right? That is, to me, is a very important perspective, a very important approach. Sorry, back to you, Chas.
Oh yeah, I think that that kind of hits on kind of one of the things I was moving in that direction, and I think kind of this is I think what Polo said as well about things being kind of domain specific, and it might change from domain. There's a very kind of useful insight, and that like there might you kind of really have to think about it in the context of where you're giving the explanation, because that might change how you're going to formulate that, and that kind of leads into like kind of the human component of things. So like Karina, like in your view, what do you think, how, like if somebody's going about trying to figure out how to make things more interpretable or understandable to their humans that are going to be consuming the output of it, or going to be consuming, try the details about how the model was built, like what are the things they should be thinking about in order to kind of help make things more understandable?
Yeah, so I'll point to the draft paper again, that 4 principles paper, because I think this touches on the sort of key elements of the system. Again, the meaningfulness, the accuracy, the knowledge limits. And I think one thing to consider when you're sort of thinking about the audience is understanding that there may be trade-offs between your goals. And so going in with the idea of knowing what goal you're serving is helpful. So for instance, if I'm, I have my system and I'm like, okay, I want it to be meaningful, accurate, etc. There's a potential trade-off between the accuracy of the explanation and how meaningful it is for a certain audience member. So for instance, an accurate explanation might be, here's the code. But if I'm a user, that is meaningless to me. So then you might say something very simple. I picked route A because of traffic. And you may lose some detailed information there, but now as a user, I can understand, oh, well, traffic is driving what predicted route I should take. So considering those trade-offs are important. And then just considering those elements alone, I think are really important. Yeah.
Awesome. And then I guess like one kind of last question for the the entire panel before we kind of like head off, or before we kind of open up for like a Q&A is like what are kind of some best practices and recommendations, like if you're somebody that's getting started building a data science team or kind of working to build models for the data that you're using, what are some best practices that you can incorporate today to kind of make sure that things you're building hopefully lend themselves more to being interpretable rather than just like black boxes that nobody understands how we got to the results that we got to?
Maybe I can start, and I think Karina already mentioned some of these. I think number one to me would be to learn more about the users, like who you're building that system for. And a lot of times it could be the really end users, like people who are using it, but sometimes it's also people in the middle. Often I would call it the model brokers, if you would. So that means they could be people who are auditing the model. They also need to know about what the model is doing. And I think currently a lot of tools or techniques are developed for the experts, like people who are building, as Karina said, well, show them the code. Yeah, they're happy to just look at the code. But yeah, often explanations are that people who are really using, like for example, you're building something for criminal justice, it could be the judge who are using the method, right? And yeah, so I think that would be the number one. Yeah, get to know the user, and don't just do it at the end. I think often, even in academia, is often oh, here's a fantastic technique, have a paper. Okay, now let's think about other people. That's too late. Yeah.
I think I'll build on that to say that at least on our team, we have found a multidisciplinary approach to be very beneficial. So there's a lot of components to explainable AI. There's the computer science element, the data science element, an engineering element. There's a visualization potentially element. There's the cognitive element. There's just a lot of elements. So at least with us, we have found considering this to be a multidisciplinary problem has been really helpful, so that, yeah, you're not halfway down your pipeline and then you go, oh, wait, we totally missed, some aspect of what's important here.
Just a quick word from me. I think I said a lot of these things already. I think it has to start by asking yourself or your organization what explaining means to you, right? And I think of those in a couple of different ways. Identifying the documentation that is needed for explainability, and then identifying everybody in the decision pipeline, and how and when are they involved in the explanation, right? I said earlier, always start with the assumption of full transparency. And anytime you limit that information, you need to be able to document why you decided to limit a certain piece of information or feature or whatever that driver was, right? So it's important to document that. Last but not the least, I would say run a pilot program. If you're starting off, run a pilot program. Learn from the pilot program, maybe run a couple of pilots, come up, if you're a larger organization like FIS, where we have so many businesses with 55,000 employees with 7 or 8 major business verticals, we try and come together and come up voluntarily based on consensus, certain standards of how we're going to try and explain our models. If capital markets is explaining their models a certain way, how can banking, how can payments, the credit debit business align with the way they're explaining their models? At the end of the day, if you have a client who has multiple products from across FIS, let's say with capital markets, with banking, with payments, we want to make the company look like it's being consistent. And does not just look like, but be actually to a certain extent consistent with our approach and how we are approaching this problem. Yeah.
Awesome. That's fantastic. Thank you guys so much. And I think we'll open up for questions from the attendees at this point. And I don't know if we've got any yet, but if not, I do kind of have like one kind of like future looking question, which is, given where we are now, like where do you think this kind of field is heading in like the next 5 years or so, and what kind of advancements do you think we'll see in being able to explain the models that we actually are using?
Yeah, I can say it in a few words. I think that the good thing on the good side, I think more and more sectors or industry sectors, and I think more companies are going to see the importance of that. I know there's a reason for that, political policy reasons and all those, but I think also is for just for people, so now they get to know more about these technologies, how they are being used every day, so they have to question, and so I think one big direction for the field is that there will only be more of them. But then from a research side, I can also speak to general trend is I would expect there will be a lot more techniques that are, as I said, there are a lot of them are postdoc, but I would expect there will be more work that come out that is more integrated to the development of the model, the training of the model. Kind of think of it as going to like the contributing to the earlier part of the building of everything, and not just at the end, but in the beginning. And there's also an area that our team has been actively working on. So that's more from the research perspective. Yeah.
Anyway, we have had some questions, kind of maybe just a couple that have trickled in, but obviously I want to open this up for anyone. If anyone has any questions, we've got them. If you go on the chat, I do have those questions listed. I've also included the draft that Karina referenced a couple of times. So if anyone wants to access that, and as well as some comments from interesting comments regarding the discussion from the audience. So I haven't seen any new questions come in, but I think that's because you guys have been so thorough in the program. And so before we close, I did want to share our events for the rest of, at least for the rest of this year. And I'll share this real quick. I'll show the screen here. But obviously we had our Explainable AI event today. On June 8th, we're going to have an event titled Return on Data. Dr. Beverly Wright is going to be moderating a fireside chat with a couple of our local executives to talk about real return on investment from their investment in data, specifically in advanced analytics. August 10th, also an event that's going to be hosted by Dr. Wright, which showcases she's part of another local organization that does more data science and AI for good, called Athletics. And so we have a standing event every year where we showcase one of their team's use cases. They work on basically pro bono type of projects in analytics and data science for different nonprofits. In September, we'll be partnering with the Transportation and Supply Chain Society on an analytics event. And then in October, we're going to be partnering with the Data Governance Society on Executive Roundtable. And then our Innovation Awards, which is our signature event. And we're still in the planning phase to determine what that's going to look like for 2021. So all this is available on our site. If you go to tagonline.org and go to the Data Science and Analytics Society page, you should be able to see all that. But before I close, I just want to thank Chaz, Karina, Polo, Rajiv for this is a tremendous session. I mean, I learned a lot. Hopefully the participants on that were able to log in were able to learn a lot and come away with some actionable items, especially if you've already started marching down the road. This is obviously, when you talk about ethics and you talk about biases and explainability and interpretability, these are all very human-centered topics that are important, obviously, for this technology to be leveraged for good. So all of you for participating, and also want to thank Blair and the team at Newton for serving as our event sponsor. Again, this event is going to be recorded and is going to be published for consumption on the TAG website in the future. And if there aren't any questions, we'll go ahead and again, thank everyone for logging in. We appreciate your participation, and thank you to the panel and Blair again. Everyone have a wonderful Wednesday and a great rest of the week.